Today we're going to talk about parallel and perpendicular lines. Parallel and perpendicular lines are one of the topics that Rene Descartes used extensively in his geometric works on the coordinate plane. Parallel lines, simply put, are two or more lines that never intersect. There's always the same amount of space between them. They run right alongside each other infinitely. You could think of a set of railroad tracks, for example, as being parallel. Parallel lines are given by the symbol of two little parallel lines straight up and down. The important thing to remember about parallel lines is that they have the same slope. If two lines are parallel, the slopes are identical. Perpendicular lines are lines that intersect, forming a right angle. Remember, a right angle is an angle that measures 90 degrees at the point of intersection. The symbol used for perpendicular lines is simply two little perpendicular lines. The important thing to remember about perpendicular lines is that they have negative reciprocal slope, meaning the slopes are flipped and the sign is changed. In our first example here, we have an original line and we want to find the slope of a line that is parallel. In the first one, the slope of the original line is 4. Because parallel lines have the same slope, the slope of the parallel line is also going to be 4. How about the slope of a line that's negative 1/2? The line parallel, once again, is going to have the same slope, negative 1/2. Finally, we have a line that has 0 slope. We construct a line that's parallel, and guess what the slope of that one is? You said it, it's 0, because parallel lines have the same slope. Now let's talk about perpendicular lines. Lines that are perpendicular have negative reciprocal slope. Our original line has a slope of 4/1. Change the sign and flip it upside down. Our perpendicular line has a slope of negative 1/4. How about the line perpendicular to the original that has a slope of negative 1/2? Flip it upside down, change the sign, it's 2/1, or simply 2. Now finally, the last one, we have the original line was a horizontal line. It had a slope of 0. How about the perpendicular line? If the original was horizontal, the perpendicular must be vertical. What do we know about vertical lines? The slopes are undefined. And so we have a perpendicular line with undefined slope. Or, to think of it another way, if the original had a slope of 0/1, the new one has a slope of negative 1/0, and we can't divide by 0. In our first example today, they want us to write the equation of a line that is parallel to negative 3x plus 6 and has a y-intercept of negative 2. Whenever you see the word parallel, you should think same slope. The slope of the original is negative 3. They want us to use a y-intercept of negative 2. Y equals mx plus b, and so y equals negative 3x minus 2. On the second example, they want us to write the equation of the line that is perpendicular to y equals negative 3x plus 6 and has a y-intercept of negative 2. When you see the word perpendicular, you should think of negative reciprocal slopes. Since the original has a slope of negative 3/1, the perpendicular will be 1/3. Y equals mx plus b. Y equals 1/3 x minus 2. In example 3, we want to write the equation of a line that's parallel to y equals 1/2 x minus 9 and passes through the point 8,1. We know that parallel lines have the same slope. We also know that we're given the point x and y, 8,1. Now we have two options. We could use the point slope formula, or we could use y equals mx plus b. In this example, I'll use the point slope formula, but you could go either way. I'll plug the slope of 1/2 in, plug in the x1 and y1, and now I'll simply distribute my 1/2 and bring everything over to the right-hand side. So the perpendicular line is y equals 1/2 x minus 3. Now, I'm sorry, that's the parallel line. That's y equals 1/2 x minus 3. Example 4, they want us to write the equation of a line that's perpendicular to 2x minus 6. Once again, I identify the original equation had a slope of 2 over 1, and I have an x and a y. Since perpendicular lines have negative reciprocal slope, the slope of the perpendicular will be negative 1 over 2. I can now use the point slope formula, or y equals mx plus b, to find the equation. I'll simply plug in my values into the formula, do my distribution, and collect everything over to the right, so y equals negative 1/2 x plus 8. Example 5 is probably the most interesting of them all. We have the slope of line AB, it's 2 over 3, and the slope of line CD is x minus 2 over 6. The lines are parallel, so we know they have the same slope. So the slope's 2/3, and x minus 2 over 6 must be equal. Having one fraction on each side of the equal sign, we have a proportion, so we can cross multiply. 6 times 2 is 12, and we have 3 times x minus 2. Go through and solve, and we get x equals 6. Working with parallel and perpendicular lines is actually pretty simple. Really, the only rule you need to know is about the slope. Parallel lines have same slopes. Perpendicular lines have negative reciprocal slopes. Using the slope formula and using the point slope formula, you can write an equation of any line that is parallel or perpendicular to another given line.